Straight line graphs. We're going to be finding the equation of straight line graph. Hit pause, copy the lesson objective down. Once you've done that, hit play, and we'll move on to the starter. Okay, so here's your starter. Hit pause, attempt all three questions. Once you've done that, hit play and we'll go over them. Okay, so let's go through these questions. Multiply it for a 25% increase. So we're starting at 100, adding 25% on, so that's taking us to 125%, which is equal to 1.25 in decimal. So there's our multiplier. Round to one significant figure. So after the 1 here, everything else is going to go to 0. 3 is not up to 5, so to one significant figure is approximately 10 million. Question 3, tax problem. Personal allowance 11,500, 20% of tax on the first 33,500 of taxable income, and then 40% where the income is greater than 33,500. What I like to do is draw a little bar graph and fit the numbers in. So the first 11,500 is tax-free. So that's tax-free, no tax on that. Then the next 33,500 you pay 20% of tax on, so let's do that. 33,500, that's going to be at 20%. And then anything greater than that is going to be taxed at 40%. 11,000 and 33,500. 10,500 plus 33 gives us a total of 45,000. So we've got £5,000 left. That's going to be taxed at 40%. Now then, to find the tax here, I do 0.2 or 20%. I'll use the multiplier times 33,500, and that gives me on my calculator £6,700. And here I calculate 40%, so 0.4 times 5,000, and that gives me £2,000. So the total amount of tax is going to be 6,700 plus 2,000, which is equal to £8,700. Okay, so what I want you to do now is to make any corrections necessary and rate your work. Don't forget to leave a comment as well. Okay. Right, let's get back to straight line graphs. Okay, so straight line graphs. It's a nice little recap lesson for you. Hopefully you remember that the equation of a straight line graph is given by the form y is equal to mx plus c, where m, if you remember, is the gradient, and c is what's known as the y-intercept, i.e. where the line crosses the y-axis. So some notes for you to make. Hit pause, copy that down, and pretty much all we're going to be doing, y equals mx plus c. How do we find the gradient and how do I find the intercept? Okay, once you've done that, hit play and we'll look at our first graph. Okay, so let's have a look at this example. This is our graph. the nice grid, and this is our straight line. Now we know the formula for the equation of a straight line. That's y equals mx plus c. So we need to find m, the gradient, and c, the intercept, the y-intercept. Okay. Now, first things first, when I look at this line, is the gradient positive or negative? Well, it's positive because the line slants towards the right, which means that as x gets bigger, y also gets bigger. So they both are increasing functions. Okay. Now I know that it's a positive gradient. Next thing I've got to look at is I need some points on the graph where I can select where it crosses the grid nicely. Here's one. Here's another one. Can't use that because it's halfway between 2 and 3 on the x-axis. I can use that point there. I can use that one. I only need 2 of these. Any 2 will do. And then I plot a horizontal and vertical to meet. So just like that and like that. So I've chosen those 2. That means I can now find my rise and I can find my run here. Okay? Just run. The rise is going to be equal to, on the y-axis, 8 take away 5, which is 3. And the run is going to be equal to 4 take away 3, which is 1. So my gradient, or m, is equal to 3 divided by 1. Oops, sorry. Let's do rise divided by run. And that's 3 divided by 1. That's better, which is equal to 3. So m equals 3. So I've got my first bit. Now I need to find c. C is the y-intercept. Where does this line cross the y-axis? And it's there at -4. So the equation is given by y is equal to m is 3, so 3x, and it's plus c, but c is -4, so -4. And that's the equation of this line. So I can write it on the graph. Y is equal to 3x minus 4. Okay. So what I want you to do is just make a sketch. It's not going to be accurate. Just make a sketch in your on your notes there of this example. Now, the question that most students ask is, why do you choose those 2 points? The points don't matter, they're irrelevant. I just picked nice points along the grid. I could have chosen this point here and this point here, and then drawn my line so they meet. So I draw a horizontal and a vertical like so. In this case, the rise is 1, 2, 3, 4, 5, 6, and the run is equal to 2. So the gradient is the same, is equal to 6 divided by 2, which is 3. So the gradient is always 3, wherever we select it. Okay, so any of those points is fine. So like I say, hit pause, make some notes. Once you've done that, let's take a look at another example. Okay, so we've got another example here. Same sort of thing. We need to find the equation of this straight line, y equals mx plus c. Whoops. So y equals mx plus c. Once we see a straight line, we know that's its equation. Okay. Again, as x gets bigger, so does y. So we've got positive gradient. And then we need to select points along the curve where it crosses the grid nicely, so it have nice numbers. That's 3, 9. That's perfect. I could take that point there, or that one, or that one. Any of these. I just need 2 of them. Any 2. They've crossed nicely. So I'm going to select those 2 there. That's going to give me, I can find my gradient then, because that's my rise of 2, and the run is 1. So the gradient m is equal to rise over run, which is equal to 2 over 1, which is 2. So m equals 2. Now I need c, the y-intercept. Where does the line cross the y-intercept? And it's there, at 3. So our equation is given by y is equal to mx plus c. So in this case, y is going to be equal to 2x plus 3. That's our equation of the straight line. I can write it on the graph anywhere along the line. Y is equal to 2x plus 3. Okay, so hit pause and copy that down. Remember what we said. We could have chosen any of these points that correspond nicely. Could have chosen this one, going across to that point there. And the gradient is exactly the same. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Divided by 1, 2, 3, 4. 8 divided by 4 is 2. So the gradient is 2. Whichever points you pick out. Okay, so hit pause. Make some quick notes. Once you've done that, hit play. And we'll look at another example. Okay, so looking at our third example, equation of a straight line again. If we look at this line here, we can say that it's definitely not as steep as the first two, which means the gradient is less. It's a shallower line, so our gradient is going to be less than the other two. So our equation of a straight line again, remember, is y equals mx plus c. So let's find the gradient first. M is given by the rise over the run. So if we pick out some nice coordinates on the graph, there and there, we've got our rise of 1 and our run is equal to 2. So the gradient is going to be equal to 1 divided by 2, so half. So I like fractions, so I'm going to leave it as that. M equals a half. We tend to use fractions if we can. You can write 0.5 if you want to, but nicer to write that. And then C, where does the line intercept the y-axis? Remember, it's where it intercepts the y-axis, and it's there at y equals 1. So C is equal to 1. So y equals mx plus c. So we can say y is equal to sub for m and c, a half of x, and c is 1, so plus 1. And that's our equation of this line. As you can see, the gradient is shallower, it's a half in this case. So along the line somewhere I can write y is equal to 1/2 of x plus 1. So hit pause, copy the example, quick sketch of the graph. Once you've done that, hit play and we'll look at one more example. Okay, so let's have a look at this example here. Equation of a straight line. Looking at this line, there's something different about it. So as x gets smaller, y gets bigger. So they're going in different directions then this time. So we've got a negative gradient. So our m is going to be negative. Y is equal to mx plus c. The gradient, m, we're going to measure it in the same way. Rise over the run. And we're going to select two coordinates, there and there. So if we select this point here and this point here, then we can see our rise is going to be equal to 1, 2, 3, 4, and our run is equal to 1, 2, 3, 4, 5. So our gradient is going to be rise over run, 4 over 5, and the intercept, the y-intercept, c is equal to 3. So equation of a straight line, and we sub for m and c, so y is going to be equal to m, 4 out of 5x, plus c, which is 3. Fantastic. Okay, so make some quick notes on that. And I've got a couple of questions I want you to have a go at. Okay, so I've got 5 lines here, which I want you to find the equations of for me. So what I want you to do now is hit pause, find the equation of all, 6 lines. Find the equation of all 6 lines. Once you've done that, hit play, and we'll check your answers. Right, for 1, you should have y equals 2x plus 3. For equation 2, you should have y equals 3x minus 5. For equation 3, gradient, remember, is going the wrong way. So it's going to be a negative gradient, y equals minus x plus 6. Equation 4, you should have y equals a half of x minus 2. Equation 5, y equals minus 4x minus 9. And for question 6, you should have y equals 3/4 of x. And the intercept is at 0, so there's no need to write it down. Okay? Good. I've got some questions for you. Okay, so we're just practicing skills today. And starting at question 1, I've got 8 questions for you to complete. They won't take you very long at all. Okay. On this question, question 4, to find the gradient, what you've got to do is you've got to find the difference between y and the difference between x. Okay, so the gradient is going to be 8 minus 2, which is 6, that's the rise, and the run is 3 minus 1, which is 2. So 6 divided by 2, which is 4, gives you your gradient. Okay. And up to question 8. Okay, good luck.